Hi all, I am ASWATHI. Currently, I am pursuing my master's degree in microbiology at the Central University of Tamil Nadu. Today, I am talk about bioremediation of toxic waste site. As we all know, bioremediation is a natural waste management. It's a sustainable biotechnological method using microorganisms such as bacteria and fungi that break down the environmental pollutants into less toxic substances. This method is mainly rely on the microbial metabolism. They break down into less toxic compounds and them used as a food source, and the product is converted as CO2 and water. They promote the cleaner environment. Then uh, I'm talk about mainly toxic waste site. Then what is toxic? Toxic waste can cause death or injury to life. A waste is considered as a toxic. It can be poisonous, carcinogenic, mutagenic, teratogenic, and bioaccumulative. Teratogenic means causing birth defects, and bioaccumulative means high concentration in the food chain. These toxic waste mainly comes from industrial, agriculture, and medical field. These toxic waste can be divided into three general categories: chemical waste, radioactive waste, and medical waste. Chemical waste is included as carcinogenic, teratogenic, and um, then radioactive waste such as elements and um, elements and compounds. They can absorb or produce ionizing radiation. They react with many materials. Medical waste is a broad spectrum waste area spanning from tissues to body fluids. They carry infectious disease causing organisms from containers to hold them and transfer them. World's most dangerous chemical toxins called dirty dozen categorized as persistent organic pollutants, example DDT, hexachlorobenzene, and toxaphene. These persistent organic pollutants are resistant to natural degradation, and they are hydrophobic, toxic due to the aromatic ring and low solubility. The microbial activity lacks enzymatic machinery to degrade the organic pollutants, persistent organic pollutants. Then we move on to types of bioremediation. I'm talking about in situ bioremediation part and their methods. In situ bioremediation, as I already said, the microbial activity convert the organic environmental pollutants into less toxic compounds. Without excavation and human intervention, they treat the contaminated soil or groundwater on site. It's a require less physical work and prevent people from spreading contaminants to other location. Then in situ bioremediation again classified as intrinsic bioremediation and engineered bioremediation. As I already said, the microbial activity leading the in situ bioremediation at on-site, we provide oxygen and nutrition to bacteria to degrade the organic pollutants. And what is intrinsic bioremediation? Intrinsic bioremediation without any human intervention, naturally occurring microbial population. The main limitation is that it's a longer time required to achieve the target level pollutant concentration degradation. Then what is engineered bioremediation? Engineered bioremediation is an advanced process of application of engineered system. We stimulate the microbial activity for remediation of environmental pollutant. Main limitation of this process is the ineffective reactivity with metal contaminant that are mixed with the organic pollutants. through physical and chemical condition optimization, vigorously vigorous the growth of microorganism by through this method. Then we move on to bioremediation in situ techniques: biobending, sparging, slurping, augmentation, stimulation, and phytoremediation. First, we move on to biobending. Biobending, as we can see in this picture, there is a two tubes. Through this tube, injection of air and oxygen supplied to the indigenous microorganism to stimulate the growth. By slowly introduce the air into contaminated soil, directly activate the microbial community, then these microbes oxidize the contaminants into carbon dioxide, water, and biomass. Several factors negatively affect the biobending process, such as moisture content, low permeability of soil, and highly saturated soils. Biovending is also applied for remediation of petroleum hydrocarbon contaminants in soil through supply of air supplied to an unsaturated soil zone using a combination of pumps and blowers for continuous injection of low volume of air. Successfully remediate the soil contaminants by petroleum contaminant, chlorinated solvents, and organic chemicals. Then next we move on to biosparging technique. Biosparging, we can see there is a injection pot, addition of nutrients through this pot, and air, gas, and gas phase nutrients added into this method. Then pressure into these nutrients and gas are added to saturated zone to promote aerobic degradation. Microbial community promote the aerobic degradation. In this method, volatile contaminants removed from the saturated zone by volatilization. Main advantage of this method: the air contact with the groundwater dissolution happens, and groundwater facilitate the support of aerobic biodegradation. Benzene, ethyl benzene, xylenes are successfully removed by biosparging method. Biosparging is most often recommended at a site impacted with low weight petroleum hydrocarbon contaminants such as diesel and jet fuel. Lighter contaminants such as gasoline is to be easily mobilized into unsaturated zone and physically removed. Heavier contaminants require longer longer remedial interval, because to reduce the microbial bioavailability with increasing carbon chain and length. It in the cost can be reduced by the diameter of the injection pot, reduced by reducing the diameter of the injection pot. Then bioslurping. Bioslurping is also known as a multi-phase extraction. Multi-phase extraction, that means it simultaneously extract the non-aqueous phase liquids and air, gas in soil. Non-liquid phase and liquid phase and gas in oil phase is extracted simultaneously through a single vacuum pump. We can see this is a slurping tube. It's a straw-like tube. They goes into the underground, and they suck into the bit of water and oil. Vacuum pump is act as a vacuum cleaner. They take oil and water and some air through hydrocarbon or water separator, suck the oil from the water, and water goes into water treatment. After water treatment, water is discharged. Through the air treatment, air is cleaned and letting it to be out. Then the uh, gas surrounding in the underground facilitate the microbial degradation. Finally, this process, underground gas facilitate the microbial degradation of the oils left in the soil. Finally, this process, air is cleaned and leftover oil is cleaned by microbes, and water is cleaned. The main limitation of this process is limited to 25 feet below the ground surface, as contaminants cannot be lifted more than 25 feet. Then bioaugmentation and biostimulation. Bioaugmentation means we add the bacterial culture to boost the pollutant breakdown, while in the case of biostimulation, we add the nutritional supplement to boost the bacterial metabolism. Mainly petroleum pollutants are degraded through biostimulation method, and bioaugmentation method, chemical and natural organic chemicals and compounds removed by bioaugmentation process. Then what is phytoremediation? Phytoremediation is the use of plants to produce use of plant and its products for the decontamination and stabilization of the contaminants from the soil. The phytoremediation is mainly classified as phytodegradation, phytostimulation, phytovolatilization, phytoextraction, rhizofiltration, and phytostabilization. Phytodegradation means the soil contaminants are absorbed by roots and accumulate in the shoot, leaves and stem. And phytostimulation, roots immobilize the contaminants by adsorption or precipitation. Phytovolatilization അത് ഓർഡറിൽ കൊടുക്കണമല്ലേ.